Welcome to our lecture video series in Integral Calculus. For our first lecture video, we will discuss the Introduction to Indefinite Integrals. Anti-differentiation, or also known as integration. Now, why anti-differentiation? Now, in differential calculus, we have the given function and then we will find its derivative. But in integral calculus, given the derivative of a function, we will find the function. So that is why integration is called anti-differentiation. The required function is called the integral. So the answer here, or the function, is called the integral. And the process of finding it is called integration. The given function is called the integrand. Then the symbol is called the integral sign. Now, according to Theorem 12, two functions having the same derivative differ only by constant. Example, we have the function x squared plus 1 and x squared plus 2. If we derive x squared plus 1 and x squared plus 2, they will arrive at the same answer, which is 2x. Therefore, we can conclude that the derivative of x squared plus the arbitrary constant c is equal to 2x. Now let's go to the power formula. In deriving, the derivative of u raised to n is equal to, bring down the exponent n, copy the base u, then minus 1 the exponent, then you will have the derivative of u. Now for the anti-differentiation, you put plus 1 in the exponent. So of course the exponent is n plus 1. So you bring down n plus 1, copy the base u, minus 1 the exponent n plus 1. So that means the exponent becomes n. Dividing both sides by n plus 1, we can cancel this portion here, and the answer will be u raised to n, derivative of u, and then this portion here goes to this portion. Now what just happened is the integration, wherein the integral of u raised to n du is equal to u raised to n plus 1, then over n plus 1. Then don't forget plus arbitrary constant c. Now, how do we understand this? Or how do we use this? Going back to integrating the 2x a while ago. So remember that 2x is the answer for the functions x squared plus 1 and x squared plus 2. Now if we integrate this, so we have the integral sign 2x dx using this pattern. So copy the base u, then plus 1. So remember that in differentiation, you minus 1 on the exponent, but in the integration, you plus 1 on the exponent. So n plus 1, and then whatever happens here will be copied in the denominator. So if the exponent is n plus 1, so the denominator is also n plus 1. And don't forget the plus c. You will understand later why there's a plus c. So looking at this solution here, integral of 2x dx, that is equal to 2x. Then the exponent is 1. Of course, this is imaginary 1 there. So that is 1 plus 1. So what happens here is imitated in the denominator. So 1 plus 1. So the answer there is 2x squared over 2. Cancel 2. So what's left is x squared plus c. So if you look at it closely, it goes back to this function, x squared plus c, wherein c is an arbitrary constant that could possibly be 1 or 2 or 3 or 4 or whatever constant. So that is why it is an arbitrary constant. So that's how we come up with this formula, which we will be using later on. Now, general properties of indefinite integrals. For the integral of du, the answer will be u plus c, where c is an arbitrary constant. For the integral of du plus dv plus ds, you just distribute the integral sign and you can integrate them one by one, term by term. Then for the integral of arbitrary constant du, that is equal to c integral of du, wherein c is the arbitrary constant. Remember that only the constant can get past the integral sign. So you cannot put outside any variable except the constant. Okay? Now we will now answer the following exercises. So let's answer examples 1 to 5. Then for the next video, we will be answering examples 6 to 10. So exercises, integrate the following and check by differentiation. If you notice, what we did here a while ago, when we solve for the derivative, so we got the 2x, and then when we integrate 2x, we were able to arrive on the function. So meaning, for you to be able to say that your answer is correct in integration, you must be able to bring it back to the original function. So that's why we will check by differentiation. Okay. For example number 1, let's apply the formula a while ago. So we have there the integral of u raised to n du, that is equal to u raised to n plus 1, then all over n plus 1 plus c. Don't forget always the plus c. If your answer, your answer is only this part here and you forgot c, then I will mark it wrong. So safe to say, always put c plus c on your answer so that you will not forget that there is a plus c on your final answer. Okay, let's solve for number 1 using that pattern. So that is equal to, so we copy the base. So using this pattern, the base here is x, then the exponent is 3. We plus 1 for the exponent, then what happens on the numerator, what happens on the exponent becomes the denominator. So that is 3 plus 1. Then plus c. Remember that if you remove this already, the integral sign, then that means plus c emerges. So it's just for you to not be able to forget the plus c. So this becomes x raised to 4 all over 4 plus c. And this is the answer. Okay? It's quite simple. So let's check by differentiation. So checking. So we have their derivative of x raised to 4 over 4 plus c, that is equal to, what happens in derivative is we copy the, this is actually equal to dx 1/4 x raised to 4 plus c. So that is what happens in derivative is you copy the base, bring down the exponent, of course becomes 4 over 4, then you minus 1 the exponent, then plus derivative of c is 0. So final answer here is x raised to 3. So notice we were able to get back on the original or the given here. So if this matches, then be happy, that means it's correct. Now for number 2, we have there the integral of 6x squared minus 4x plus 1 dx. So using again the pattern, let's solve this. So let's distribute the integral sign. This is integral of 6x squared minus integral of 4x, I forgot dx, minus integral of 4x dx plus integral of dx. So that is the pattern for this. Then using the other pattern, which is here, we can put outside the integral sign the constant. So you can do that. So it's like this: 6x squared dx minus 4x dx plus integral of dx. Then using the pattern, we have there 6. So let's use so x raised to 2 plus 1 all over 2 plus 1 minus 4 multiplied with x. So we have there 1 plus 1, 1 plus 1. And what happens here? How about this part here? This is actually integral of x raised to 0 dx. Why? Note that x raised to 0 is actually equal to 1. So this becomes x raised to 0 plus 1 all over 0 plus 1. Now since the integral sign was removed, you put here the plus c. Simplify, we have there 6 over 3 reduce to lowest term. So this is the final answer. Checking by differentiation. So, what is the derivative of 2x raised to 3 minus 2x squared plus x plus c? This is equal to this 2 bring down 3x 3 minus 1 minus 2x 2 minus 1 plus we have there x raised to 1 minus 1 plus the derivative of c is 0. That is equal to 6x squared minus 4x raised to 1, and then we have there plus x raised to 0 is 1, and then plus 0. So this is now equal to 6x squared minus 4x plus 1. So we were able to match the given with the derivative. So that means it is correct. So that is for example number 2. Let's go for example number 3. Again, using the same formula pattern. Now this is equal to, so let's distribute again the integral sign. And then 3 dy minus integral of 2y raised to negative 2 dy. This is 3. Then this is actually y raised to 0. It's just as stated earlier. Y raised to 0 is equal to 1. So minus 2y raised to negative 2 dy. So using the pattern, so y raised to 0 plus 1, then that is 0 plus 1 minus 2y raised to negative 2 plus 1 all over negative 2 plus 1. Then since the integral sign was removed, you put there plus c. So we have here 3y minus 2 over 1. That is actually negative 1. So if that is negative 1, it becomes positive here. So y raised to negative 1 plus c. So the final answer here is 3y plus 2y plus negative 1 plus c. So 3y plus 2y raised to negative 1 plus c, or this is 3y plus 2 over y plus c. Now for checking, the derivative, so d dy, so derivative of 3y plus 2y raised to negative 1 plus c, so that is equal to, so 3 bring down 1, y 1 minus 1 plus 2 bring down negative 1, y negative 1 minus 1 plus derivative of c is 0. So that is equal to 3 y raised to 0 plus, this becomes negative, so negative 2y negative 2, okay, no more, then that is equal to 3 minus 2y raised to negative 2. So again, it matches the given negative 3 minus 2y raised to negative 2. That means our process is correct. So that's for number 3. For number 4, okay, let's have this radical sign. So what we do here when we come with radical sign is to convert it into exponent so that it becomes easier to solve. This actually is equal to t raised to 1/2 minus t raised to negative 1/2 d. So that is equal to distribute. So we have the integral sign. So integral of t raised to 1/2 dt minus integral of t raised to negative 1/2 dt. So using the pattern again, we have there t raised to 1/2 plus 1 all over 1/2 plus 1 minus t raised to negative 1/2 plus 1 all over negative 1/2 plus 1, then plus c. So this becomes t raised to 3/2 all over 3/2 plus, no, I think it will not become plus, so minus t raised to 1/2 because at the denominator we have a positive 1/2 plus c. Then we have the 2/3 t raised to 3/2 minus 2t raised to 1/2 plus c. So we can have this as an answer, or we can have an answer here is equal to 2/3. This is t multiplied with t raised to 1/2 minus 2t raised to 1/2 plus c. So this is 2/3 t square root of t minus 2 square root of t plus c. So we can have this also as an answer. Okay, so that is for number 4. Now let's check by differentiation. Okay, by differentiating, so we have there checking. So what we have here is the ddt of 2/3 t raised to 3/2 minus 2t raised to 1/2 plus c. So we will derive this. It is equal to 2/3 bring down 3/2 t raised to 3/2 minus 1 minus 2 bring down 1/2 t raised to 1/2 minus 1, and derivative of c is 0. So we cancel this one out. So what's left is t raised to 1/2 minus, so we cancel this one out also. We have there t raised to negative 1/2. So this is equal to square root of t minus 1 over square root of t, which is the same with the given for number 4. So our process is correct. So this is for number 4. Our last example for this video is number 5. Again, using the pattern, same pattern. Now, this is quite different from what we have done because you cannot distribute this integral sign easily because it is in a form of the parenthesis here is locked by an exponent, meaning you cannot just distribute anything inside the parenthesis because of the presence of the exponent of greater than 1. So what will we do here? Take note that having this exponent 4 means that it is n in our pattern, and that having this base here, base for the exponent, means that it is the u in the pattern. So let u is equal to the 3x plus 3, the base. And for us to be able to accomplish or to complete the pattern, we need to find the derivative of u. So for the derivative of u, that is equal to 3 dx. So the derivative of 3x plus 3 is 3 dx. Then we will follow this pattern so that we will be able to execute this pattern on the right side for the answer. So using the formula, so integral sign of the u, so our u here is 3x plus 3. The n here is 4. The du here is 3 dx. Now we have a problem. This is not similar with the given because of the presence of a constant 3. So for us to balance this solution, we need to put 1/3 outside the integral sign, so that if we cancel this one out, we will go back to the original equation. So what is the importance of the 1/3 here? So this remains, the 1/3 remains, and then this portion here will be set aside. So that is equal to 1/3. Then execute the pattern here. So the base 3x plus 3. Then we have the 4 plus 1 exponent. The denominator 4 plus 1. Then plus c. Take note, we didn't do much, or we didn't do anything here in the 3dx. So we only focus on this portion. So the final answer here is 3x plus 3 raised to 5 all over 3 times 5, that becomes 15 plus c. This is the answer. Now let's find out if what we did is correct, if this really is the correct answer, by differentiating the answer. So differentiate d, so d dx. So differentiate 1 over 15, 3x plus 3 raised to 5 plus c. So let's differentiate this. That is equal to 1 over 15. Bring down the exponent 5. Copy the base 3x plus 3 minus 1 the exponent, then don't forget, derive what is inside. So 3 dx. So deriving the base here, we have the answer as 3. So that is equal to, so 15 over 15, 3x plus 3 raised to 4, that is equal to 3x plus 3 raised to 4. And this is similar with our original function here, given. So that is for number 5. So it will take practice. It is best that you find other exercises for this, and the more you practice, the more faster you will solve these kinds of problems.